Okay, so we're doing some antiderivative steer integration with natural logarithm. And to start with, let's actually take the derivative, differentiate this one. So when I go the derivative, I get 3. The derivative of ln x is 1 over x. And so you get 3 over x as the derivative. So hence, if I want to evaluate this integral, I know then that this is going to be, y is going to be 3 ln x. And the key that I need to look for is when I have a 3, if I rewrite this integral x to the minus 1. Because the reason what happens when I do integration, I know it's going to be, I take my, when I add 1 to the exponent, that would give me a 0. So if I would get a 0, that's a key for me to recognize that it's not the power rule, but it's actually going to be the natural logarithm scenario. And so what we can say is we can generalize this. If I have 1 over x, which is x to the minus 1, then I know it's going to be ln of x plus c. Okay, so if I want to try this one here, in order to do it, the first thing I'm going to do is I'm going to simplify this. This x squared belongs with each term. And so I end up with 3 e to the x plus 4x minus 6 plus 2x to the minus 1 minus x to the minus 2 dx. Okay, so now when I actually come along and take the integral of e3 to ex is just e to the 3x plus, well, here I'm going to add 1, so it's a squared. And so I think about my coefficient, it's going to be 2, because that will make the 4, minus 6x plus, well, I come over here and I go minus 1, I add 1, I get 0. Oh, that's the one that I'd be careful of. This is going to be the natural logarithm because it's x to the minus 1. I can't have an x to the 0, so it ends up being 2 ln x. And then the last one here, I have minus an x. I take this, I add 1 to the exponent. I add 1, it gives me negative 1. And so this negative and the negative will come down, make it a positive plus c. So when you're doing the power rule, be very careful of the exponent of x to the minus 1 because that will give you a natural logarithm. I'm going to try this other example here. So when we have this scenario here, I know I can rewrite this as 1, not as 1, but I can rewrite it as 1 minus 2 to the x to the minus 1 dx. And so because the minus 1, I know that I'm going to have natural logarithm of 1 minus 2x. But I have to be careful here because I know when I take the derivative of this inside function will have a derivative of minus 2. So I have to counteract this minus 2 by dividing by the reciprocal of that value. So I'm actually going to have to divide by negative a half plus c. So if I take the derivative of this, I end up with 1 over 1 minus 2x times negative 2, which cancels out with the 1/2. All right, let's try this one now. I want to determine h of x if this is true. Well, when I look at this, and I'm given this initial boundary condition, so I can actually find the full function, in order to evaluate h of x, I'm going to have to simplify what is going on in this integral. So that means I get x squared plus 2x plus 1 when I expand out the top to the power 2 over x squared dx. Don't forget your dx, good notation. And so if I keep simplifying, well, this x squared belongs with each of these. So that means it's 1 plus 2 over x plus 1 over x squared dx. Well, which is the same as 1 plus 2x to the minus 1 plus x to the minus 2 dx. Now I'm ready to do my integration. So 1 becomes x plus, well, here to the negative 1 means it's going to be ln x. The next one is I'm going to add 1 to the exponent. Think about when it comes down, so change the sign, plus c. Now I was told that h at 1 is negative 2. So h at 1 is equal to negative 2. So that means this is going to be negative 2 when my x is 1. So I plug 1 in for all these values, and I get negative 2 is equal to, well, 1. The natural logarithm of 1 is 0. This is going to be minus 1 plus c, which cancels, and so c is equal to minus 2. And so my function h of x is going to be, here using this one here, x plus ln 2 ln x minus x to the minus 1, subtract 2.